Hello everyone, today I want to present to you Aru, a real-time AR rowing coach developed in collaboration by researchers from Harvard University and ETH Zurich. Rowing is a sport that requires physical strength and endurance, as well as a precise rowing technique, in order to achieve this smooth, beautiful, professional movement. I would say it is fairly quick to learn how to row. You basically just have to follow these 6 steps. That will easily get you to this. Oh, well, actually, we might want to go back and add a few more biomechanical principles and physics law, which definitely makes it not easy for someone to master rowing. The motivation behind our work is the current lack of quantitative feedback to rowers and coaches, which requires experienced coaches to observe a rower, visually detect mistakes in technique, and then verbally describe necessary changes to the rower. External sensors surely can provide some quantitative metrics, but they are often very expensive, and also they tend not to give actionable feedback to a rower. Augmented reality can be used to provide real-time feedback by using embedded visualizations, which has made it very interesting for sports. On the one hand, it can be used to enhance the fans' experience, but on the other hand, it can also be used to enhance the training and the practices. In this work, we present Arrow, a real-time AR rowing coach. Our goals are to assist rowers and rowing coaches during training, on the water and on rowing machines, and to provide them with real-time quantitative feedback that is hard to catch by sight or with sensors. In order to achieve these goals, we have created an application that is able to detect an athlete's movements in real time and displays that together with relevant performance metrics. Arrow also provides feedback on our borrower's body movement and stroke sequence, and can help synchronize the movement between different rowers. Let's go through the Arrow pipeline. From both tracking algorithm, we obtain a set of key points that we then process in order to detect angles and strokes. We then use them to provide performance metrics, feedback on a rower's body movement and stroke sequence, and a comparison to a ghost rower, together find a user interface. Let's go through the real-time computer vision part of our work. We perform 3D human pose estimation using BlazePose, a lightweight convolutional neural network architecture for human pose estimation. It detects 3D coordinates of 33 key points in a human skeleton at over 30 frames per second, making it perfect for real-time applications. We then compute various body angles during the rower stroke, upper body, knee and elbow angles. To then detect the different phases in the stroke cycle, like the catch, the leg drive, the body opening, the arm bending, and the finish, we employ a set of heuristics that are based on the obtained angles. By tracking handle direction changes, we identify the start and the finish of each stroke, and we then extract the different stroke phases by using the body angles and the biomechanics of rowing. Let's move on to the interactive visualization of our features. We provide 3 performance metrics: stroke rate, drive time, and body angles, all shown per stroke. Here we can see an arc diagram of the body angle at the finish position, and we can observe the difference between the current finish angle and the angle of the previous stroke by looking at the portion highlighted in gray or dark teal, based on whether it decreased or increased. We can also scroll through the line chart to see the changes in the finish angle over time, for every stroke. Let's move on to the second category of features that Arrow offers, the feedback on a rower's body movement and stroke sequence. Arrow can provide feedback on the handle eye throughout a stroke cycle by highlighting the path that the wrist follows and encoding the handle speed by color. We can observe, for example, that this rower has a bump in the handle eye at the beginning of the drive, which is easy to detect using the app and then can be addressed. Another important feature of our application is feedback on the order and timing of the movements in the stroke cycle. In rowing, the drive phase consists of three main activation phases: the leg straightening, the body opening, and the arm contracting. These movements are performed sequentially with a slight overlap between two consecutive phases. Arrow uses a pipeline view to visualize this sequencing. It highlights in red parts of the stroke sequence where the athlete starts muscle activation too early, which is a very common mistake. In addition, we can give more detailed feedback on the timing of a rower's body opening on the rower. We indicate the position of the hip at the beginning of the leg drive and the position of the hip where the body opening should begin, which is where the knees are forming a 90 degrees angle. The red area is showing the amount the body was opened too early. We do something similar with elbow bending. If the rower bends the elbow before the legs are straight, a red arc will appear on the elbow. And again, it is possible to see when the elbow began bending for each previous stroke by scrolling through the line chart. Finally, let's go through our last feature, the comparison to a ghost rower. Arrow can record the movements of a rower and then overlays that on top of another rower. We align both skeletons at their feet, which is the only part of the body that isn't moving during a stroke. This feature can be very helpful to synchronize the movements of two rowers that row on the same boat, or to compare oneself to a professional rower. Let's go through the implementation of Arrow. Arrow is built for iPad Pro using Xcode, Swift 5, and the Charts library. It employs MLKit for pose estimation, which is a mobile SDK developed by Google, but it utilizes a more accurate model from MediaPipe. The feedback can then be streamed to other iOS devices via iOS AirPlay for real-time rowing feedback. In order to evaluate the app, we conducted a small user study with 4 participants, including rowers and a coach. After introducing Arrow and its features, participants were left free to explore the app by recording a rower on the erg. They were then asked to fill out a post-study survey. The feedback showed that participants were very interested in receiving quantitative feedback on body angles and on stroke sequencing, as there are no other accurate and real-time options available. Visualizing performance metric over time was also highly evaluated, with an average rating of 4.75 out of 5. They were then also asked to evaluate the features in terms of usefulness, usability, and fun factor, as we can see from these Likert scales. All participants reported that they would like to use the app in the future. Finally, the ghost rower overlay was also rated by 2 more rowers who usually row in doubles. They rated it 5 out of 5 for usefulness and said they would find it beneficial for synchronizing their movements, as no other feedback method currently provides that. Let's talk about the future plans of Arrow, which include incorporating automatic core detection from water rowing, providing detailed information on oar angles, stroke length, and efficiency. And we also aim to expand Arrow's capabilities to support multiple rowers in a team boat. We obviously hope our work inspires further research in this field. And we would all like to thank you for listening to our presentation. I'm ready to receive any question you might have.